In this video, we're going to learn about naming compounds that now have polyatomic ions. Polyatomic ions are going to be covalently bonded group of atoms. Specifically, all the atoms that are in there are going to be nonmetals. The important thing is that in polyatomic ions, they carry a net electrical charge. Compounds with polyatomic ions may be present in some chemicals that you may be familiar with from everyday life. So, for example, when it comes to Epsom salts, the chemical formula for the compound that is present is MgSO4. And I'm going to highlight the polyatomic ion, which is SO4. Next, we have baking soda. The chemical formula for the compound in baking soda is NaHCO3. The polyatomic ion is HCO3. Lastly, in bleach, the main component of it is NaOCl. The polyatomic ion specifically is this OCl. When we're given chemical formulas and we need to name a compound with polyatomic ions, we are going to see that when it comes to the cations, there's going to be several types. We can have metal cations, and previously we learned that metal cations can have one charge or multiple charge. Additionally, there's only one polyatomic ion called ammonium that has a positive charge. The chemical formula for an ammonium is NH4 positive 1. Because those cations need to be paired with anions, we can have anions, just like we observed before, that they are based on non-metal elements, or polyatomic ions can also be anions, as we're going to see in a future slide. When it comes to polyatomic ions, it's important to remember that we are going to specifically put polyatomic ions in parentheses when you have more than one as the subscript that is assigned. So, for example, here we have the compound BaOH2. BaOH2 is composed of barium, which is a cation that comes from group 2A, and is made out of hydroxide, which is specifically a polyatomic ion of overall -1 charge. As we have done previously, when it comes to this value of 1 becomes the subscript of the barium. This subscript of 2 is the subscript of hydroxide. And since we are assigning a subscript of 2 to a polyatomic ion, as it says in the last bullet point, we need to put them in parentheses. Let's now practice how to go. Let's look at a list of polyatomic ions, and then let's practice name to chemical formula. For this course, the most common polyatomic ions are summarized in table 3.5. You are responsible for knowing the chemical formula, the charge, and the name of the polyatomic ions. You will be tested on the content of all the information that you see in table 3.5. Now let's go from name to chemical formula to just see how we write the chemical formulas for these ionic compounds. In this practice, we are given names and we need to write the chemical formulas for these compounds. I'm going to do all of the examples here in order for us to practice. On letter A, it says that the name of my compound is aluminum chlorate. Aluminum has the symbol Al, is +3 because it lives in 3A. Chlorate is going to be ClO3 -1. When I do the 4 steps that we have learned previously for going from name to chemical formula, what I'm going to do is take this one and assign it as the subscript of aluminum. I'm going to take this 3 and assign it to the subscript of chlorate. So at first, when I write my answer, I'm going to write Al1 ClO3 3. But you can see that it looks kind of weird because right now it looks like ClO3 3, but it looks like O33. Remember, when we are writing chemical formulas, if you assign a subscript of 2 or more to polyatomic ions, you must put them in parentheses. Here, aluminum, we need to erase that subscript of 1. So the correct chemical formula for aluminum chloride is Al in parentheses, ClO3, and outside of the parentheses, 3. Let's look at example B. We have ammonium oxide. Ammonium is NH4, +1. So this is a polyatomic cation. Oxide refers to oxygen, and it has a charge of -2 because it lives in group 6A. We are going to now take the charge, make it the subscript of ammonium, take this one, make it the subscript of oxygen. So my final answer here is NH4 in parentheses, subscript of 2, and then O without the 1 next to it because subscript of 1 is always omitted. Let's go through the next one. In letter C, I have magnesium bicarbonate. Magnesium has a charge of +2. Bicarbonate is HCO3 -1. When I make the value of the charge the subscript, I notice that this is going to be as a final answer, Mg in parentheses HCO3 2. Let's now do letter D, sodium nitrite. Sodium is Na, and it has a charge of +1. Nitrite is NO2, and it has a charge of -1. In this case, because the charge of the cation cancels with the charge of the anion, all I have to write is just the atoms. So my final answer is NaNO2. Notice that in this case, for example, the subscript that NO2 has is a 1. So you must not write parentheses. The parentheses are only utilized when your polyatomic ion gets assigned a subscript of 2 or more. Let's do the last one, copper 1 sulfate. In copper 1 sulfate, we have Cu +1, and I know that copper is 1 because of the Roman numeral. Sulfate is SO4, and it has a charge of -2. So this means that this 2 is going to be the subscript of copper. This 1 is the subscript of the sulfate. So I'm going to write Cu2SO4. If you mistakenly put parentheses on the SO4 and a 1. Remember that all of that is omitted. When a polyatomic ion has a subscript of 1, you must not write the 1 and you must not write the parentheses. So the final answer for this is Cu2SO4. Let's now do the other work. Now that you're given chemical formulas, let's determine what is the name of the compound. The main thing that you must do when you do this, and for now, because you're practicing and learning, you must identify what is my polyatomic ion. This is why it's essential that you're familiar with the information given in the table that I presented you in slide 16. So I'm going to first identify all the polyatomic ions on each of the chemical formulas that we have here. I'm going to highlight them. In letter A, my polyatomic ion is CO3. On letter B, my polyatomic ion is OH. In letter C, we have CO3. In letter D, it is NH4. In letter E, it is NO2. And in letter F is SO4. Those are my polyatomic ions. Now that I have identified them, I need to recognize that when it comes from chemical formula to name, I need to remember all the rules that I learned previously for naming metals with one charge, metals with multiple charges, and now additionally, we're going to incorporate for some of these, the non-metal stem followed by IED and the name of polyatomic ions, which in the case when of polyatomic ions, you just use the name of the polyatomic ion. So if you have an NH4, you use ammonium. If you have, for example, CO3, you have carbonate, so on and so forth. So you can see now that when it comes to ionic compounds, there's great variation on the different types of ionic compounds that we can have out there. So let's start with letter A. In letter A, this is an occasion in which I have a metal element with one charge. Sodium lives in group 1A. Because that is my combo, I have a metal name with a polyatomic anion. So all I'm going to write here is name of the metal, sodium, followed by the name of the polyatomic, carbonate. I'm going now to move on to letter B. As my metal, I have something with one charge. Ca, calcium, lives in group 2A. So I just need to write its name, followed by the name of the polyatomic ion. OH, its name is hydroxide. So the name of the chemical formula on letter B is calcium hydroxide. Let's now move on to letter C. In letter C, I have MnCO3. Mn, which refers to manganese. Manganese is one of those metal names that require a Roman numeral because manganese is a transition metal. So when it comes to this, I'm going to break this chemical formula into its corresponding ions. I see that there's not a number next to the Mn, or there is a number outside parentheses of CO3. So that means that if I break these into ions, at first I'm going to write Mn plus 1 and CO3 minus 1. Let me write in the work how I determined that that was true. Since CO3 doesn't have parentheses and a number of 2 or more, that means that technically, even though it's omitted, it has parentheses with the subscript of 1. Similarly, manganese doesn't have a number next to it, so there is a 1 in there that is omitted. So when I take this value and make it the superscript, because it used to be the charge of manganese, and I take this 1 and I make it as the charge of CO3, these ions at first appeared to develop this chemical formula. If I revise the table of the polyatomic ions, I can notice that CO3 is not -1. CO3 is actually -2. So that means that if I combined it with a cation and there's no subscripts, this is one of those instances that the charges cancel each other. So this means that overall, manganese has a +2, carbonate has a -2, and because they cancel each other, that's how this chemical formula resulted. Now that I have the correct charges for my metal variable charge cation and my polyatomic, I can go ahead and name this compound, which this is going to be manganese, Roman numeral 2, carbonate. Let's now move on to letter D. I have a ionic compound in which I have ammonium followed by a non-metal anion. If ammonium is my cation, then I just write the word ammonium. Next, since this is paired with sulfur, I have to use the nonmetal stem for sulfur followed by IAD. So sulfur becomes sulfide. Let's do letters E now, or letter E and F. On letter E, I have tin. Tin is one of those elements that even though it doesn't live where group B is, where the transition metals are, it behaves like a transition metal. So I must break this chemical formula into ions and determine the correct charge for my components. Here, I must determine that this 2 outside of the parentheses used to be the charge of the tin. The tin doesn't have a number, but there's a 1 that is there, but it was omitted. And this 1 used to be the charge of NO2. So if I write the ions, I have SN plus 2, NO2 minus 1. By recombining these two, I obtain this chemical formula. So that means that these are the correct charges for each of the ions. And additionally, if I go to my table of polyatomic ions, nitrite, which is NO2, it is -1. So the name of this compound is going to be tin Roman numeral 2 nitrite. Let's do the last one, which is Au2SO4. As we have done before, you see that the SO4 doesn't have a parenthesis and a subscript. That means that there is 1 that it is assumed, which means that there's a subscript of 1. This 1 is placed as the charge of that gold. This 2, because the subscript used to be the charge of the SO4. So the ions that these came from is Au plus 1 SO4 minus 2. We go to our table and we see that indeed SO4 is minus 2, so we can name this compound. And the correct name for it is going to be gold, Roman numeral 1, sulfate.